In this video, I'll introduce you to setting up database files for your application data. In our sample application, the starlog activity is supposed to create, retrieve, update, and delete starlog entries. And if we create such entries, data in the database, Android offers the small yet performant file-based database system SQLite. File-based means that there's no database server running, but instead the database exists in the database file in the file system. Fortunately, Android offers enough classes for the most common database tasks to make handling SQLite databases as painless as possible. But it gets even better. For setting up an SQLite database for our application, we'll only make use of one high-level class, the class SQLite OpenHelper. Okay, so let's get going. In our simplified example, the only classes that need to leverage the database are starlog and logedit. Let's begin with starlog. To avoid duplicate code across multiple classes leveraging databases, it's common sense as well as best practice to factor out database functionality in a separate class. In most cases, you also factor out that class into a separate package. So first of all, let's create a package for our database code. By clicking on this application package, selecting New, Package, and I'll just call it .db at the end. So in this case, EU Android Training DT4000.db. Click on Finish. Then right-click on the package, select New Class. Now the package field is pre-filled. You could have, by the way, just right-click on this package name, select New Class directly, and enter the .db up here. It's completely your choice. I now want to create a class that handles starlog entries for me, so I call this class starlog DB Manager. Click on Finish. So now I have a specialized class, and its sole responsibility is to handle database access for starlog. And like I said, we'll use the SQLite OpenHelper class to handle all database access. So for this database manager, we create our specialized version for that helper class. So I'll define an internal class, private final class dbHelper, extends SQLite OpenHelper. This class requires a constructor. So I hover over the squiggly line, select Add Constructor. And it also needs to implement a few methods. So I again hover over the squiggly line and select Add Unimplemented Methods. And then we let our starlog DB Manager class hold one instance of this dbHelper class. Private mdbHelper of type dbHelper. So now let's have a look at the dbHelper class again. The first parameter of the dbHelper's constructor is the context. This will come from the activity which uses this DB Manager. For example, in the starlog activity, I'll have an instance of my DB Manager, private starlog DB Manager, DB Manager, and then I want to instantiate this, DB Manager equals new starlog DB Manager. And when instantiating, I'll pass the context, which means this activity. We'll also have to create a fitting constructor. So I hover over the squiggly line and click Create Constructor. Instead of starlog, I change the parameter to context, and the name as well to context. And then I'll save the context for later. mContext equals context. Then I need a field for that. So I create this field. I move this constructor a little down below our helper class, right there. So now we have the context for our helper class. And we instantiate the DB helper not when our starlog DB Manager is created, but when the method open is called. mdbHelper equals new dbHelper. The first parameter is the context. which leads us to the next three parameters. That's the database name, the database factory, and the database schema version. But we don't need them handed in from the outside. We can manage them here. So I'll delete those parameters and also take them out of the constructor. Instead, I provide static constants that carry the database name and the schema version, which I now can enter into this superclass constructor. We don't need a factory, so I set it to null. If you ask yourself why we do this, I'll tell you that the reason is that it's common sense and best practice to keep the knowledge, the database name and the schema version, encapsulated within this StarlogDB Manager class. No other class need to know about the database name and the schema version. There's still some errors, so let's have a look. Here we need mContext instead. This is to be called from the Starlog class and should open the database. I'll save the database instance in another property, which I pull from our DBHelper class by calling either getReadable-database for write-protected database, or if I want to write data as well, I'll take getWritable-database. Define this as a field, create field MDB. Now the great thing about that helper class, SQLite Open Helper, is that it handles database creation for you. And it handles it lazily. So only when you access this database by calling getWritable-database, it will look for a database file called dt4000db. And if it's not there, it will jump right to the method onCreate. So what you need to do here is provide the code to create the database. And that's as simple as calling a database statement, which you also define as a class constant, right here. This is pretty plain, straightforward SQL. Creates a table with the fields ID, content, and timestamp. And now I can use the database's execSQL method with my just created constant as a parameter. Okay, so far for that. But when your application matures, it might very well happen that you'll need more fields for a database table. That's where the schema version number comes into play. This is right now sort of the first revision of this database schema. And by specifying this number here, Android will keep that number within the database. So every time it opens the database, it checks whether there's an updated version of this database scheme. And it does it by comparing this schema version number to the one that's saved in the database. And if this one is higher, it will jump straight to the function on upgrade and runs the code it finds here. So in the simplest case, it will simply drop the database table and create a new one via the onCreate method. And the SQL statement for dropping a table is as simple as this. Drop table if exists, Starlog. So with that in place, you have all you need to have Android retrieve or create the database as needed. Let's see that in action. Switch to the DDMS perspective. Select the emulator, go to Data, Data again, and scroll down to the package name of our application. In this case, EU Android Training DT4000. And now we'll have Android create the database for us. I've forgotten one thing. Since it only creates the database after the open method is called, we'll have to call this method here. MDB manager dot open. Now let's go to DDMS, hit run, the emulator. Now keep your eyes peeled for this directory. There's our app. See? Now there it is. There's a folder called Databases. And there's our database file. You see, no juggling of database files for yourself. There's a little complexity to this setup, but it's pretty straightforward. And all you have to master is a little tiny bit of SQL language. That's all.